Problem 6 reads, a tuning fork is attached to a toy tank that moves away from a child and toward a wall at a speed of 2.46 meters per second. The frequency of the fork is 400 hertz. What is the beat frequency heard by the child, produced by the interference of the sound waves reaching the child directly and those reflected from the wall? The speed of sound is 331 meters per second. Let's take a look and listen to that tank. As the tank moves away from the child and toward the wall, the child will receive sound directly from the tank and also sound from the tank that has reflected off the wall and back to the child. These two sounds will be of different frequencies and will produce beats. The result sounds something like this. We're given the following information. The frequency of the tuning fork is 400 hertz. The velocity of sound in air is to be taken as 331 meters per second, and the velocity of the tank towards the wall is 2.46 meters per second. With that information, you're to find the beat frequency. Try to solve that problem now before watching its solution. We will use our equation for the Doppler shift to find, first of all, the frequency heard by the child for the sound coming directly from the source. In this case, the frequency of the source is 400 hertz. The speed of sound in air is to be taken as 331 meters per second. The velocity of the observer is 0, the child is at rest, and the velocity of the source is 2.46 meters per second. It is away from the observer and therefore is to be negative when put into our equation. Using our equation and putting in these values, we would have f sub 0 is equal to v, 331 meters per second, plus the velocity of the observer, which is 0, divided by 331 meters per second, minus the velocity of the source, which is minus 2.46 meters per second. And this is to be multiplied by the frequency of the source, 400 hertz. If you carry out that calculation, you should find that this gives a frequency of 397 hertz. All right, so that's the frequency heard by the child directly from the source. The other thing of consideration here is the frequency of the sound that is reflected from the wall. So the sound from the source travels towards the wall, reflects off of the stationary wall, and back to the child. If we could find the frequency heard by an observer at the wall, so imagine that there is an observer here, and we calculate the frequency heard by that observer, that will be the same frequency that is heard by the child. For that case, the velocity of the source is towards the observer, and therefore v sub s is going to be positive. The velocity of the observer is again going to be 0. The velocity of the sound is the same as it was. The velocity of the source is the same as it was. If we calculate that, we have velocity of sound, 331 meters per second, plus the velocity of the observer, again 0, divided by 331 meters per second, minus plus 2.46 meters per second, again times the frequency of the source, 400 hertz. And if you calculate this, you will find that to three significant figures. This turns out to be 403 hertz. Now the beat frequency will simply be the difference between these two frequencies. 403 hertz minus 397 hertz gives me a beat frequency 6 hertz. All right, that's the solution to our problem. Let's move on then to our seventh and last problem.